I'm going to start with a few facts about polynomial functions. Fact number 1. The degree is the highest power of a polynomial. Number 2. The maximum number of real zeros or x-intercepts is always the degree. And fact number 3, the maximum number of turning points is always 1 less than the degree. Now, a turning point is a point where the graph changes direction from increasing to decreasing, or from decreasing to increasing. Now let's look at a graph. We'll analyze it. Suppose a graph looks like this. And this is an example of a cubic function, meaning that the degree, or highest power, is 3. Now let's take a look at how many real zeros there are. This particular graph has 1, 2, and 3 real zeros. These are also called x-intercepts. Okay, so take a look that the most that we could have is 3, which is the same as the degree, and this particular graph does have 3. Now looking at the turning points are where the graph changes direction. So over here on the left side, it is increasing, and then here in the middle, it's decreasing, and then on the right side here, it is increasing again. So these particular points that I highlighted are called turning points. Got one there and one there. Also, they are a maximum, relative maximum, and relative minimum. So yeah, turning points are really maximums and minimums, and they can be relative maximums and minimums depending on how the graph is shaped. So turning points are always relative maximums and relative minimums. So for this particular graph, we have 3 real zeros, which are also called x-intercepts, and we have 2 turning points, the maximums and the minimums. Now let's take a look at another function. Now without graphing it, we should be able to tell what the real zeros are and the turning points. The degree of this polynomial is 4, so that means that we have at most 4 real zeros. It also means we have at most 4 x-intercepts. Also, the turning points will have one less, so we have at most 3 turning points. Now keep in mind, I'm saying at most, or the maximum number of. It doesn't mean that we have 4 exact real zeros or x-intercepts. We could have less than that. And it doesn't mean that we have 3 turning points for this problem. Again, we could have less than 3. But we cannot have any more than 4 real zeros. We cannot have any more than 4 x-intercepts, or any more than 3 turning points. Looking at the graph, I'll go ahead and graph this function. Y equals 2 x to the 4th minus 5x squared plus 1 zoom 6. Alright, so looking at the graph, it goes down, it increases, it decreases, and again it increases. We've got 1, 2, 3, 4 real zeros, just like we said up here. Those are also called x-intercepts. And looking at the turning points, where it changes direction, we've got one there, got one here, and over on the right. So we do have 3 turning points for this particular problem. Let's look at another one. The function is f of x equals x to the 5th minus 3x to the 4th plus 9. Now we know the degree. The highest power is 5. So that means we have at most 5 real zeros, and we have at most 5 x-intercepts. We also have at most 4 turning points. Now let's go ahead and graph this one, see what it looks like. X to the 5th minus 3x to the 4th plus 9. Zoom 6. Alright, now this graph goes up. We have a maximum here, relative maximum. Then it goes down, decreases, down to this point, which would be a relative minimum, and then it increases again. Alright, so looking at the turning points, we have this maximum and minimum. We only have 2 turning points for this particular polynomial, although our rules say we could have at most 4. Well, it turns out we have 2. And looking at the zeros or x-intercepts, we've got 1, 2, and 3. So we only have 3 real zeros or 3 x-intercepts. Again, the rules say we can have no more than 5.